Hey, how's it going, guys? One of my students asked me to show them the algebra of the derivative of y equals cosecant inverse of x. We're going to slightly change it up, and we're going to go ahead and find first the situation that is a little bit more general. We're going to do x over b instead of just regular old x. Is going to allow us to generalize, and then later we're going to make the b equal to a 1. So first, we're going to take our cosecant of both sides of the equation. By doing this, we've removed the inverse idea, and now we just have regular old cosecant, and this is going to make our problem a lot easier. Now we implicitly differentiate. We recall that the derivative of cosecant is cosecant cotangent. Don't forget to put your dy over dx as part of your implicit differentiation there. And then the derivative of x over b is going to be just 1 over b. From here, we're going to go ahead and rearrange really quickly. We're going to solve for dy over dx. So solving for dy over dx, we're going to end up with 1 over b multiplied by, and to get rid of this, we have to divide both sides by cosecant cotangent. Don't forget that one of them must be negative. So when you are dividing by cosecant, though, dividing by cosecant is the same thing as multiplying by sine. So because it's the same thing as multiplying by sine, we now have the sine of y, I forgot my negative sign, I just told you not to forget, times, and again, the tangent of y now, because again, we divided by cosecant, dividing by cosecant, same as multiplying by sine, dividing by cotangent, same thing as multiplying by tangent. We're actually almost done, but unfortunately, we have a bunch of y's on the right-hand side, and we want this to be in terms of x. To make that fix and to do it, we're actually going to go back to this step right here, and we're going to go ahead and draw a triangle based on this step. So the triangle we're talking about here is a basic old right triangle that has an angle of y and a hypotenuse over an opposite of x over b, because cosecant is 1 over sine, the reciprocal of the opposite over hypotenuse. So it is the hypotenuse over the opposite. Using some basic Pythagorean theorem, our a squared plus b squared equals c squared, we can rewrite this bottom part as square root of x squared minus b squared. We can now go ahead and write our nearly final answer to our problem here. We have 1 over b multiplied by negative, and the sine of y here is going to be the opposite over hypotenuse. That is going to be b over x, and our tangent of y is going to be b divided by square root of x squared minus b squared. And now, just to write our beautiful final answer in formula format, we're going to say our derivative with respect to x of the cosecant inverse of x is in fact equal to, well, the b's cancel, but we still have 1b on top, so we have a negative b on the top. And on the bottom, we have x times the square root of x squared minus b squared. I forgot my b in my actual part here, but you know, that's okay. Life goes on. Have a wonderful rest of your day, and peace out, everyone.